In this example, we are going to determine an inflation rate. And inflation is the increase in the prices of goods and services that affect our everyday lives. Inflation is usually measured at an annual rate. So here we have in 1960, the cost of a first-class postage stamp was 4 cents. In 2020, a first-class postage stamp cost 55 cents. What was the annual rate of inflation on the cost of a first-class postage stamp from 1960 to 2020? So we can use the future value for compound interest to help solve this one. And of course, what we're going to do is we're going to glean through this paragraph here and look for the variables that we need. So in 1960, the cost of a first-class postage stamp was 4 cents. So that was the initial amount right there. Start out at 4 cents. I'm going to put down P, and here is 4 cents, 0.04 of a dollar. In 2020, a first-class postage stamp cost 55 cents. So it initially started at this, ended up at this. So this is our future value. So we'll put down our future value of 0.55 of a dollar, 55 cents. What was the annual rate of inflation on the cost of a first-class postage stamp from 1960 to 2020? So the time span, T, 1960 to 2020, that's 60 years. And then we can think that N, the number of compounds, well, we're just looking for an annual rate. We could say that the number of compounds is 1, even though it's not really compounding. We could still use the compound interest. We just make our compound as once, that one time a year. Because the rate is what we're looking for. That's R. So now we have our future value, 55 cents. That's going to be equal to our principal, that's 0.04. 1 plus R, that's what we're looking for. But look at this, R divided by N, and N is 1. So R divided by 1 is just plain old R. So I'm just going to write it like that. And we'll close it off. Then N, that's 1. We multiply that to T, that's 60, so we'll raise this to 60 years. So then using algebra, don't forget we're looking to isolate the R right here. So the first thing we could do is we could divide out the 0.04, the 0.04, the 4 cents. This will go, and that'll go. 0.55 divided by 0.04. So this is 13.75. That's equal to the 1 plus R to the 60th power. So the next thing we'll do is we'll go ahead and we will use the power rule of exponents. So we'll go ahead and we'll raise this to the 1/60th power because I need to deal with that exponent there. And algebra says what I do on one side, got to do on the other, so we'll raise this to the 1/60th power. These will cancel, that's the whole idea. And then 13.75 raised to the 1/60th power. So 13.75. Here's our caret key, raise that to the 1/60th power. And then hit enter. So we have 1.04465,217. That's going to equal to 1 plus R. We finish off our algebra by subtracting 1 from either side. So then R is approximately equal to 0.04465,217. So the rate of inflation from 1960 to 2020, the rate was around 4.465% annually. And there you go.